Hello everybody and welcome to my class. My name is Woody. I will be your professor today on this incredible journey we're going to take through Archimedes' principles. So I invite you to sit back, relax, take copious notes, and snore loudly if you would. Who here's seen Titanic? Most of you? Okay. So I remember the first time I heard the story, I kept wondering how such a large ship could hit an iceberg, right? And why did they not see the iceberg better? I mean, surely it's massive enough that, it must be able to be seen. And in reality, that's not the case. And we can thank Greek mathematician and philosopher Archimedes for that. You see, folks, an iceberg, most of it is underwater, okay? And the reason for that, okay, the reason that ice floats and the reason that we're studying hydrostatic principles is to have a broad understanding, a knowledgeable understanding of how hydrostatic pressures affect the body, all right? And to do this, we're going to start at the very beginning. So hydrostatic pressures inside the body and hydrostatic fluids, very important for how our circulatory system works, how physiological fluids in your body are uptaken through different channels. It's a very broad spectrum, okay? So Archimedes' principle states that an object wholly or partially submersed in a fluid is buoyed up by a force equal to the weight of the amount of fluid that it displaces, okay? How did it become Archimedes' principle, though? Well, let's go back in time a little bit. Let's go around 300 BC in what's now Sicily. Archimedes was there and he was tasked by a king to figure out if a crown was real gold. So what did Archimedes do? He thought to himself, you know what? I'm going to ponder this problem in the tub. So Archimedes went, he drew a bath, and as he was getting his last leg in the water, what do you think happened to the water? Very good. Yeah, the water level rise. Right. Excellent. And Archimedes jumped out, ran through the town butt naked, yelling, Eureka, Eureka, I have found it. And right then he discovered Archimedes' principle. To give you a little demonstration of Archimedes' principle, I have some visual aids here. So this is water in a clear container, okay? Empty cup right here. So this cup probably, we'll say it weighs 1/4 pound, okay? We're going to drop it in here and it's going to float. Why? Obviously it's displacing a lot of water, and the further I push it down, you see the water level appears to get more even though it's still the same amount of water, okay? Now, what Archimedes is suggesting to us is that if we change one of the variables in that, let's change the weight of the object dispersing the fluid. In this case, it'll be the cup with the writing on it. We're going to add water to it, right, as weight. And what happens? Okay, eventually it sinks because now there's more pull on gravity than is being forced up by Archimedes' principle, okay? So again, just like before, still the same amount of water. If I pour the water out, put it back in, we're floating again. And ladies and gentlemen, that is Archimedes' principle. Are there any questions? No? Thought I had one in the back. No? You're good? Okay. Well, everybody, I will see you next time when we will discuss the 4 physiological fluids of the body. Stick around. We'll be back.